Welcome to physics lesson, linear motion lesson 3, which will be starting at exactly 9:10. So get your books, your pens, and calculators ready. Remember, we shall be finalizing with the topic today by doing 2-3 examples on this particular topic. Good morning, everyone. Good morning, students. Good morning, teachers who are also following up on their students in this channel of ours. It's another fine morning. Actually, I made a mistake. We were supposed to have chemistry, but I found myself scheduling for physics. But there's no problem. Let's proceed with physics. We will have chemistry in the evening. I've seen a student saying that we will we will we can do chemistry. Maswali ya chem hiyo tutafanya jioni. That is Senbal. Hizo maswali ya chem tutafanya jioni. Mimi ndio nilijipata nimeschedule physics instead of chemistry. There's no problem with that. So in the evening at 5, the normal time for physics, we will have chemistry. So otherwise, we are only going to do some questions that will just enable you work on 2-3 questions, enable you maneuver in this particular topic. In fact, today we will just spend very few minutes, like 40 minutes, and we will be done with our topic. So I would like to know where you are watching me from. I would like to know, of course, just mark the register. Where are you? Yeah, we are starting as soon as possible right now. So our first question today is, a boulder is sliding down a slope with a uniform acceleration of 3 meters per second square. Calculate its velocity after it has slid 10 meters down the slope. So that's the question I want us to start with. Then we will do 4 others for today. So now, someone's asking Kem Zangabe. I think I've answered that question. It's in the evening, the time for the physics lesson in the evening. So I'm saying this. First of all, you are supposed to read the question, understand, then we see which equation of the linear motion are you going to apply. And by the way, these equations are not supposed to be here. They're supposed to be here in your brain. Like, I've just written there so that you understand how we use it. We have the first one, the second one, and of course the third one. Now, the first, okay, to answer Swali, then we write the available values. A boulder is sliding down a slope with a uniform acceleration of 3 meters per second square. At that particular point, we have 2 given values. A sliding object, meaning it is starting from the, it's at rest, then it starts to slide. So we have U, which is 0, then we have S, which is, we have A. So our U is equals to 0 meters per second. Our A is equals to 3 meters per second. Then our calculate its velocity. We are supposed now to calculate the final velocity. This one we don't have. Then we have S, because it is 10 meters. The question says, calculate its velocity after it has slid 10 meters down the slope. So let's do this. We have U, we have A, we have V, we have S. We are calculating V. So we can either, what I calculate its velocity, we can either use the first one, V is equals to U plus AT. Let's see. But of course, we don't have the acceleration in the first case. Oh no, we have 3. We don't have T actually. Hatuna T. Tungetumia kwanza. What about ya pili? We are looking for V. Ya pili haina V. Ya tatu, V is equals to U squared. V is equals to U squared plus 2AS plus 2AS. That one can or will give us plus 2AS. So V squared is equals to U squared plus V plus 2 times A is 3 times 10. So we have our V squared to be equivalent to 2 times 3, 6. So we will have 60. Then V, use your calculator, you will get 7. If I'm not wrong, 7.75 meters per second. So that's how you can get that particular question. You work with the third equation. Alternatively, you can calculate T using the second equation, because we have S is equals to UT. Okay, U of course times T is 0. So we have S is equals to 0 plus half A T squared. Then you get the value of T. After getting the value of T, use the first equation. But of course, that is a long method. You will be struggling to get 1 mark. You will be using a long method to get just, not a mark, 3 marks. So another question. Yes, this question will enable us you know how to calculate or to convert velocity from meters per second to kilometers per hour and vice versa. So the question reads, okay, let me write the question for you. A body in initially moving at 72 kilometers per hour, accelerates uniformly to a velocity of 180 kilometers per hour in 3 seconds. In 3 seconds, calculate its acceleration. Calculate its acceleration. Calculate its acceleration. Now, of course, this one, it deserves to be given 1 mark because of its simplicity. But why I'm doing so is because I want you to know how to convert. Because you cannot operate with kilometers per hour. We are supposed to operate with 2 meters per second. So convert kilometers per hour to meters per second. Now, we have 5 over 18 and 18 over 5. So from kilometers per hour to meters per second, multiply with 5 over 18. From meters per second to kilometers per hour, calculate with or multiply with 18 over 5. But it is very rare to be asked to convert to kilometers per hour because most of the calculation in physics are done in the SI unit, which is actually meters per second. Those who are joining us, welcome, and we are glad that you are here. So, I hope you are following us very keen and clear. I hope my body is clear. Kuna mtu anasema, hello, please change and teach angles. Which angles now? It is not mathematics. I'm teaching physics. Sawa? Not right now. Halafu tena Edna Yamoa. You cannot just say you want to change. Apana, we have to take time. Like, you know, a teacher comes when he or she knows what to teach. So wewe unafika unataka kuchange. We are doing some questions on linear motion. We are only doing 4 questions. We are in our second question. So the other one will be coming later on. I hope I'm clear. Sasa Edna. Yes. So angles, your teacher will teach. I hope Mr. Mudama is following for shifting grades. He is the mathematics teacher. For me, I teach physics and chemistry. I hope he is following us right now. But it's good to ask. It's good to request. Now, let's look at this question. First of all, convert for me the speeds or the velocities into meters per second. So, answer na hii. 72 times 5 over 18. You will get 20 meters per second. Because, okay, cancel hii, inakopea 4. 4 times 5, 20 meters per second. Then, 180 times 5 over 18. Inakopea 10. So, inakopea 50 meters per second. Velocity, acceleration is given by V minus U over T. So A is given by V, vinyl, which is 50, minus U, which is 20, over T, which is 3. So you will have A being 50 minus 20 is 30, divided by 3. So you will have 10 meters per second square. I think that is how that question should be done. That is how that particular question should be done. Yes. Before we go to the third question, let me see kama kuna mtu akona swali. Yes, someone is saying I'm following from Makueni County, my fellow teacher. Thank you, Stephen Bailey. Sawa. I hope we are fine, and you can hear me and you can see what I'm writing on the board. I want to move to another question. Tulifanya tikatayama tukamaliza. We did on our first lesson. So if you missed first lesson, can you watch? You will get some tikatayama. Linear motion lesson 1, you will find some tikatayamas over there. Yeah, we did like 3 examples on tikatayama. Haya, kuna swali hapa nataka tufanye. A body of mass a body of mass 20 kilogram is raised to a height of 3.0 meters. Determine the velocity. Determine the velocity of the body when just about to hit the ground. When released from this height. When released from this height. Yes. You got 2 ways of calculation. I will give you the easiest one. Now that, thank you Noelina Ambadha for following us today. Now, look at this. A body of mass 20 kilograms is raised to a height of 3 meters. Determine the velocity of the body when just about to hit the ground when released from this particular height. Like umeachilia iende chini hivi. In this case, daga tufanya na the obvious method, which actually we are borrowing this formula or this concept from another topic ahead: energy, work, power, and machines, whereby there is what we call kinetic energy, which is always equal to the potential energy of a certain body. So I will say kinetic energy is equal to potential energy. Remember, these are not the values to be used. If for you as a student, write kinetic energy is equal to potential energy. But also, nobody will penalize you by writing this way. Now, kinetic energy is energy of an object in motion. It has a certain velocity. Now, potential energy is the energy possessed by a body which is at a relative position from the ground. Like this body of mass 20 kg, it is at a distance 3 meters from the ground. Now, kinetic energy is given by half times mass times velocity square. That is the formula of kinetic energy, which is equivalent to potential energy, which is m, g, and h. Yes. This m and this m should even cancel out. Why? Because we are dealing with the same body. But because we are also provided with the mass, it can stay there. There is no problem. So we will say half times 20 Is it 20? Yes, times 20 times v squared. Now, when it goes down, to be equivalent to mgh 20 times g inakwanga 10 times h, which is 3. By 2 1 by 2 10. So we have 10 v squared to be equivalent to 20. By the way, wacha kusema mbona nimeweka hii decimal in maths. Dot means multiply with 20 times 10 times 3. 20 times 10 200. Sawa? Times 3 600. I have v squared goes to 60. Then what is v? 7.7. Kwani leo tumefanya maswali ya 7.7 meters per second square. Yeah, that's how it should be done. mgh is equals to half mv squared always. Like, let me explain. If I allow this thing from this, okay, my body is 1 meter. If I allow it to fall down this way, mpaka hapa chini, ikiwa hapa juu it is possessing a kinetic energy. While it is going down, it is losing. Sorry, ikiwa hapa juu it has potential energy. When it is going down, it is losing potential energy because the height is reducing, while gaining what? Kinetic energy, because as it goes down, the velocity increases. Up to that point, are we together? Let me check my guys from this other side. I hope you can still see what I'm doing, because majama wa kuna mtu anataka lenses tunaweza tukaifanya vizuri sana. I'm looking for haya, take us on questions on quantity of it. Hiyo nitafanya after this topic. That is tomorrow. Yeah, I know. I'm not sure kama itakuwa kesho. Ken Mark lesson is at peak. Ken from Kahuho Uhuru High School. Kahuho Uhuru High School. I saw your bus in our school the other day with your students. I don't know what you had come to do. I think we can organize to have lessons on lenses next week, or when you are available. Next week I will be okay. Mimi niko available always. The problem is you are going back to school, but there is no problem. See to the post, especially for those who are day scholars. Haina shida, we will do it. Change. I don't know why the exam text here. I'm laughing. I don't know, change right now and teach angles. Next time, Edna, I will change next time and teach angles. So Edna, I will change next time. Then teach angles. Sawa. I'm happy with the shifting rates. They are joining with a good number. Watu wangu wa Ambassador Speaks, we should be learning from them and be joining very well. Now, that's our second question for today. Now, let's go to another question. Oh, sorry, before I go to another question, apart from using this formula, kinetic energy is equals to potential energy, I want to try, and you will check, you will confirm with me whether it works out. A body of mass 20 kilograms is raised to a height of 3 meters. So it's ion S is 3 meters. Determine the velocity of the body. Now final velocity. Hiyo hatuna. Sawa? Kumbuka initial velocity ni 0 meters per second. Yes. Because iliachiliwa ikaanguka. Nini nyingine tuko nayo? Tuko na G 10 meters per second square. G, okay, the units of gravity inakuanga Newton per kilogram. But because we are using it now as acceleration, I'm placing it meters per second square. So, now, twende pale tuone kama kuna yenye itaingiliana pale. We are supposed to calculate V. Can we use the second equation? No, sorry, the third equation. V squared is equals to U squared plus 2AS. You remember our answer is 7.75. Let's see. V squared, hiyo ndio tunatafuta, is equals to U squared ni 0 plus 2 times A, which is now G10, times S, which is 3. So V squared is equals to 60, and V is equals to 7.75 meters per second. So you see, we have two ways of calculating it. But remember, in this method, I have not used this 20 kilograms. Hamdi Mohamud, Karisa, Kenya. Thank you, Hamdi, for that. Yes. Haya, unless kama uko na swali lingine, you can tell me. Watu wangu wa Ambassador Speaks, please, can I hear from you? Like, can you say something? Simuongee nisikie. Where are you watching me from? Aje tuende swali lingine. Hapa kuna swali. It's our either second last or third last question. So make sure you know how to operate all these questions. So a small ion ball is dropped from the top of a vertical cliff and takes 2.5 seconds to reach the sandy beach. Find the velocity with which it strikes the sand. Yes, so ndaka tufanyia hapa alafu tufanye nyingine ya mwisho sasa. But of course yeah, so we have time 2.5 seconds. Yes, that is our time. We have U, which is 0 meters per second squared. Hey, why am I saying squared? Yes. Find the velocity with which it strikes. We are looking for V. Then with which it strikes the sand. Find the velocity with which it strikes the sand. What else do we have? This is a falling object, an object that falls down freely. What are we supposed to do here? We are supposed to know that the G is 10. So this is our velocity now, acceleration, meters per second square. So venye naona, we will use the first one, that v is equals to u plus gt. V hatuna is equals to u0 plus d, which is 10, times t, which is 2.5. By the end of the day, you will have v to be 25 meters per second. Yes, that's how it should be. That is it. Aya, swali ya mwisho. Aya, swali ndio hii. Na hii ujaribu ushike vizuri. A girl dropped a stone. A girl dropped a stone from the top of a tower. From the top of a tower, 45 meters tall. And a boy projected another stone vertically upwards at 25 meters per second, at 25 meters per second at the same time. At the same time. Determine the time taken for the two stones. For the two stones to meet. Yes, it's a good question. I'm going to elaborate kidogo as you're also thinking on how the question should be done. Wewe umesoma hiyo swali ikwaje? Like, we have a girl here. Then we have a boy. A boy is here. The girl is dropping a stone. Inaenda hivi. And the boy is dropping another stone. He's projecting another stone iende juu. So they're asking, apa, at what, determine the time taken for the two stones to meet. Yes. Yeah. So hapo ndio inafaa tuiangalie. So nimekuachia ufanye hiyo swali ufikirie itakuwaje. So nataka tuanze na the boy. We are actually, I want us to use this. Yes. I want us to use that one, whereby we are going to consider the stone dropped by the girl. So S, tuanze na the girl hapa. We have S is equals to UT plus half AT squared. So EA like G, you know why. So S atuna, we are looking for S. So itakuwa S is equals to U, kumbuka U is 0 for the girl. So E yote inakuwa 0. Is equals to a half times 5, so sorry, times 10 times T squared. So itakuwa S for the girl would be 5T squared. Sawa. Twende boy. Use the same equation. S is equals to UT plus half GT squared. S is the one that we are looking for. At what time? Okay. Andika hivyo. S is equals to 25T. Pale tumeambiwa kwa hii swali, the initial velocity ya stone projected by the boy was 25 meters per second square. So to 25T plus a half, E G ni 10. So what this is, a half times 10 times T squared, 5T squared plus 5T squared. Yes. Then, kama tuko na kitu kama hiyo, can we, in place of S, we place 5T squared. So naona hii, uilete hapa, we substitute, mahali tuko na S, weka 5T squared. Because this is half and this is all, I mean this S is the half distance yenye iliteremka mpaka hapa na hii pia ikapanda half mpaka hapa. So we can equate actually the two, that 5T squared is equals to 25T plus 5T squared. How is that? Check on that. I have to look for a calculator. Just a minute. Yes, in fact, let me not reach the final. If I go to look for the calculator, you will not get it. So you will get the T when you substitute where we have S, you place 5T squared. And of course, 5T squared and 5T squared, they're going to cancel each other. If you calculate, then you tell me, as I'm looking for another question to add on top of this. But most of the questions I'm seeing here, we have actually done them. But kuna ingine ya helicopter hapa, I wish, no, hii ni mrefu, maybe tutafanya next time. Yes, so, Mbadha, do you have any question? Noelina Mbadha? Oh, amo ya alikuanga mzazi, but I know he's still following on us. Aya, kwa upande wa shifting rates, kuna mtu ameuza chemistry ni saa ngapi? Chemistry tulisema ni jioni at a particular time. So, the time ya physics ya jioni, you ndio time ya chemistry. Now, what it says is, you use your calculator to manipulate this, then you will have your final answer. I would like to stop you from there for today. Then in the evening, we will meet for a chemistry from 5 to 6. If you have any question, please let me know. Thank you. Thank you for following us. Thank you for being with us. Have a nice day. See you in the evening.